that ends the lesson on PCA. It's a very general method. People use principal components all the time. And the face recognition method is just what we use to introduce it. Although I will say it's become very well known because not just because of how well it worked and sort of caught people by surprise, but just it had this very clean interpretation. In fact, now you'll hear, instead of eigenfaces, you'll hear about eigengates. Right? So you take measurements of people walking, you try to find a principal component analysis, project them down and do it. There are eigenbody shapes, which is terrifying to think about, but basically the idea is people vary in different shapes, and I should be able to take a small number of variations and say I can fit you by just a small number of control knobs. If you're doing computer graphics animation and you want to be able to control the different shapes of people to build different characters, you want to be able to just turn a small number of knobs and have people change their overall build, their height, things like that, and you can use this principal component analysis or more sophisticated versions of it to do that. The method that I've shown you here also is a linear method, right? All these things are orthogonal, and I could compute the coefficients by just taking the dot products. And that's a nice property to have. It makes things easy to do. But it's also a liability. If I have just say a three-dimensional space, suppose I have points that actually just lie along a curve. Okay? So they're all on a single curve, which means if you just told me the value along that curve, that would represent the point completely, assuming I knew the curve. But it's not a line, it's a curve, okay? So it bends. So there are nonlinear methods of doing principal component analysis that allow you to capture sort of nonlinear lower dimensional manifolds. We won't talk about it here, but in fact there's one's called nonlinear kernel PCA. But for now, all you need to know about is what we talked about here: linear orthogonal decomposition of principal components.